Good day, viewers. You are welcome. Here we have an interesting exponential equations of 2 power of m plus 4 power of m plus 8 power of m equals 39. And what is the value of m that makes these equations equal? Let's see how we can solve this beautifully. Let's consider the solution here first. 2 power of m is in a standard form, and let's try and convert 4 power of m. 4 power of m, it means 2 power of m all raised to power of 2. And also we have 8 power of m equals 2 power of m raised to power of 3. So this one also, we can call it 2 power of 2 all raised to power of m. And this one as well, we call it 2 power of 3 all raised to power of m. All these are the rules of indices. So by coming to that equation and replace everything here with what we are going to have 2 power of m plus, so when we go for this, we have 2 power of m raised to power of 2 plus 2 power of m raised to power of 3 equals 39. So since we have 2 power of m here, here, and here, we are going to make it easy, let's let 2 power of m equals t, and we have t plus t raised to power of 2 plus t raised to power 3 equals 39. So after we have this, here is a cubic equation where we are going to take 39 to this side. So taking 39 here, we have t plus t raised to power 2 plus t raised to power 3 minus 39 equals 0. Then 39, we have to break 39 down based on this corresponding power of t squared, and t cube. We have t plus t squared plus t raised to power 3 minus. So by breaking this down, what we need here we need a number that will give us power of 3, and a number that will give us power of 2, and a number that will give us the power of 1. But everything must come from this 39. And what are those numbers? So they are very simple. Suppose I have 27 plus 9 plus 3. So 27 plus 9 plus 3, everything here, it gives us 39. Then we are going to open this parenthesis as we have t plus t raised to power of 2 plus t raised to power of 3 minus 27 minus 9 minus 3 equals 0. So we combine this with 3. They have a power of 1, that is t minus 3 in bracket, plus also we combine t raised to power 2 with 9. We have t raised to power 2 minus, but 9 here is 3 raised to power 2, plus also we combine t raised to power of 3 minus 27 is 3 raised to power of 3 equals 0. So here are the 3 things that we have here. But if we have 3 raised to power 2 minus t raised to power 2 minus t raised to power 2, and t raised to power of 3 minus 3 raised to power of 2, what we have here is very simple, as when we have t minus 3, let's say t squared minus 3 squared, this gives us t minus 3 and t plus 3. We call it difference of 2 squared. And if we have t raised to power of 3 minus 3 raised to power 3, this gives us t minus 3, then multiply by t raised to power 2 plus 3t plus 9. This is what we have for this. This is called difference of 2 cubed. And if you now consider this, here is t minus 3, t minus 3, t minus 3. Something is common to all of this. So which means we have to factor out that one, and when we factor out that one, we are going to write the remaining part of this, and then we add this together. By doing that quickly, t minus 3 is the common one there. And taking it out, this one remains 1 plus. So this one will remain t plus 3. T plus 3, and this one remains t squared plus 3t plus 9. And everything equals 0. And we have t minus 3 bracket t squared plus 4t plus 13 equals 0. And from here, we have t minus 3 equals 0. Therefore, our t equals 3. Here is the fixed value of t, but we have to find m, not t. So by recalling from where we let 2 power of m equals t. So replacing this t with 3, this gives us 2 power m equals 3. But looking at this, the base of this is 2 and the base of this is 3. They contradict. But to get the value of m is very simple, just by introducing log on both sides. By taking log on both sides, let's say log of base 2. So we are going to have log of base 2, 2 raised to power m equals log of base 2, then we have 3. So log of the same base equals 1. Therefore, the whole of this becomes m equals log 3 base 2. This is the first answer to this problem, as m equals log 3 base 2. And looking at the second one, which I'm not going to solve because this does not give us a real solution. And why do we assume that? We have what we call discriminant. For the discriminant of this is less than 0. And when a discriminant less than 0, we are going to get a complex solutions. And assume I'm only after the real solution, and only m equals log 3 base 2 gives us the real solution. If discriminant is given as b squared minus 4ac, the b here is 4, and that is 16 minus a is 1, and 4 here, c is 13, that is 4 multiplied by 1 multiplied by 13. So looking at this in a glance, we can see that 16 minus 4 multiplied by 13, so this gives us 52. And we subtract this one, we see that it is less than 0. And when discriminant less than 0, we are going to get a complex solution. Therefore, I'm going to ignore this one. So after ignoring this, then I want to try and verify for m equals log 3 base 2 if it really satisfies the given equation, as we have 2 power m plus 4 power of m plus 8 power of m. We want to check if this equals 39. M is log 3 base 2. By changing this m to log 3 base 2, we have this plus, and we know that 4 here, we can just write it as 2 power of 2. Then this is also multiplying log 3 base 2. Similarly to 8, we have 2 power of 3 log 3 base 2. And one thing here is, when we have this base of log and the base of this the same, we only take this 3. Therefore, we have 3 plus, also this 2 will come here, that is 3 raised to power of 2, plus 3 will come here, that is 3 raised to power 3, and everything equals 3 plus 9 plus 27, and that gives us 39, which shows that log 3 base 2 is the correct answer to this problem. Thanks for watching, and don't forget to subscribe to this channel. Stay tuned, see you in the next video. Never stop learning. Bye bye.